This is passage 3. It's the conflicts passage. We know it's conflicts because it says student 1, student 2, student 3, student 4. These are going to say student or scientist. It might say hypothesis or method. There's only one conflicts passage per ACT science test. Remember our DRC approach. C stands for conflicts, carefully read. It's the one passage on ACT science that it really serves most students well to break down the passage before going to the questions. It may not work that way for every single student. You have to find your own approach, but this approach works for most. So carefully read. When we get to the questions, remember, you want to read, then reread, the R&R approach. A quick read through the question and then reread it, breaking it down step by step. Step 1 in a conflicts passage is to identify the conflict, and that's usually going to tell you in the last sentence or last paragraph of the informational section. So you might want to skim everything above it. You don't have to read it super carefully. It's going to help explain some things, right? So you get the scientific names, what's being studied. You understand what an ICV is, an ink-containing vesicle. Then 4 students predicted how the number of ICVs would be affected by ink concentration and temperature. So I just wrote out at the side ink and temp and then ICV, how they each are affected by it. Step 2 is to identify the differences. And in particular, we are looking how ICVs are affected by ink concentration and temperature for each student. So student 1, as ink concentration increases, ICVs decrease. So I'm just drawing arrows to help me remember. And as temperature increases, ICV decreases. Do the same thing as student 2. Ink concentration increases, ICV increases. That's a difference. You want to note differences as you go. Temperature has no effect, so just put it on omit sign. Student 3, as ink concentration increases, ICV increases. So it's the same as student 2, different from student 1. And temperature increases, ICV decreases. So that's the same as student 1. Student 4, ink concentration has no effect, and as temperature increases, ICVs increase as well. This passage is a bit different in that it also has an experiment that was performed. That's not real common to put in the conflicts passage. Usually, it's just the student's hypotheses. And this one has an experiment that was done to prove or disprove the hypotheses. Number 14, which of the following tables, so we're looking at these tables and the answer choices, is most consistent with student 3's prediction, make sure you're looking at the correct student, about how increasing solution temperature affects ICV formation. So when we look at our tables, all the temperatures are going the same direction, right? They're increasing from lowest to highest as you move down the table. So then let's look at what ICV does. As temperature increases, ICV decreases. The only one that does that is choice H. So that's your answer. Number 15, the results shown in table 2 are consistent with predictions of which of the students, if any. So in table 2, as temp increases, ICV increases. Which of the students say that? Student 4, as temp increases, ICV increases. So student 4 only. All the others do not agree with table 2. So B. Number 16, are the data shown in table 1 consistent with student 2's prediction about how ink concentration affects ICVs formed? So student 2 says, as ink concentration increases, ICV increases. Table 1 says, as ink increases, ICV decreases. So they're not consistent. So it has to be F or G. And the table says, as ink increases, ICVs decrease. So your answer is G. Number 17, prior to the experiment, which of the following statements about ink concentration on ICV would students 2 and 3 agree? So students 2 and 3 both say, as ink increases, ICV increases. So the frequency at which tetrahymena come into contact with ink increases, and they have more frequently to be stimulated to form ICVs. So your answer is A. Number 18. Prior to the experiment, for which temperature, 22 or 30 degrees Celsius, would student 1 most likely have predicted that tetrahymena would on average produce the greatest number of ICVs? So student 1 says as temperature goes up, ICV goes down. So we want the greatest number, so it would be the lowest temperature, so 22 degrees. And why is that? It's because the membrane is more flexible or less flexible. Well, it tells us in the reading that temperature increases the rigidity, so it needs to be more flexible at 22, right? So less rigid, more flexible. So your answer has to be F. Number 19, which of the students predicted the average number of ICVs is affected by either ink or temperature, but not both? So we have student 2 says it's not affected by temp, and student 4 said it's not affected by ink. So students 2 and 4, choice D. Number 20 is a suppose question. Remember, suppose if why questions require a bit of thinking usually. Suppose it were determined that high ink concentrations would physically interfere with the ability of the membrane to form vesicles. This would strengthen prediction of which, if any, students. So we look at our diagrams, we say high ink, low ICV is the case in both students 1 and 2. But we don't see that choice over here in our answer choices, right? So now let's look and break it down. Student 1 says high concentrations of ink inhibit tetrahymena's ability to form vesicles. That is pretty much exactly what it says here. Student 2, it changes the explanation, right? Increases the probability will come into contact with and take in ink. So their answer has to be F. So luckily they didn't say student 1 and 2. That would have been a much harder question. The questions in this particular passage were all ELMI questions, evaluations of models, inferences, and experimental results. That's not always the case that conflicts is all from one category, but it is in this particular passage. Reach out if you have any questions at all, and we'll end with our silly joke. So last night, I accidentally drank a bottle of invisible ink. Now here I am, sitting in the hospital, waiting to be seen. Have a good day.